Welcome back to your science class. We are discussing about chapter 3, Atoms and Molecules. Today's topic is Dalton's atomic theory. Dalton means John Dalton. जॉन डाल्टन इंग्लैंड के फिजिस्ट एंड केमिस्ट थे, जिन्होंने 1808 में ये एटॉमिक थ्योरी अपनी दी। इस एटॉमिक थ्योरी में 6 पोस्टुलेट्स उन्होंने बताए। ये पोस्टुलेट्स क्या थे, इनके बारे में डिटेल में हम जानते हैं, समझते हैं।
Take a very quick look at the 6 major postulates of his theory. First, he said that all matter is made up of very tiny particles called atoms. Secondly, he suggested that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Third postulate was, atoms of a given element are identical in mass and chemical properties. Similarly, fourth postulate was that atoms of different elements have different masses and chemical properties. Fifth postulate stated that atoms combine in a ratio of small whole numbers to form compounds. And lastly, the relative number and kinds of atoms are constant in a given compound. I know I just rattled off the postulates. Don't worry, let us now understand each postulate one by one by taking the same example of elements A and B giving rise to compound C. The first point stated that all matter is made up of very tiny particles called atoms. It means that when we go on dividing matter into smaller and smaller sections, what we get at the end is atoms. So can we say that elements A and B are made up of atoms? Yes, in fact compound C is also made up of atoms that have combined together. So the first postulate was very easy to understand. The second postulate was that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Now what do we mean by this? Yes, it means that atoms are like the fundamental units. Dividing them further is not possible. Also, in a chemical reaction, atoms may combine together to form new units. However, no new atoms can be created and existing ones cannot be destroyed. So in this case, the atoms of element A and B are just combining to form compound C. So can we say that no new atoms are formed in this case? Yes, and similarly, no atom is destroyed. Let's move on to the third one now. The third postulate states that atoms of a given element are identical in mass and chemical properties. If we zoom into the element A, we find all the atoms that make up element A are just the same. And in what sense are these same? The atoms have identical mass as well as chemical properties. In simple words, the third postulate states that all atoms of a given element are identical. And does this explain the fourth postulate too? Yes, the fourth postulate states that atoms of different elements have different masses and chemical properties. So are we able to notice that atoms in element A are different from those in element B? Absolutely. And in what sense are they different? Atoms in element A and B have different masses and even different chemical properties. In simple words, it states that atoms of different elements are different. The fifth postulate states that atoms combine in a ratio of small whole numbers to form compounds. Now what do we mean by this? In this chemical reaction, we find elements A and B reacting and giving us the compound C. If we observe well, a unit of compound C has 2 atoms of element A and 1 atom of element B, right? So aren't these whole numbers? Yes, this means that in any compound, the elements are always present in a ratio which comprises of whole numbers. You will not find half or 3/4 atom combining with the other. In case of water, we always have 2 hydrogen atoms and 1 oxygen atom combining to form 1 unit. In 1 unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. The same holds true for all compounds. The number of atoms of a particular element in a compound will always be a whole number. Now for the last one. The sixth postulate states that the relative number and kinds of atoms are constant in a given compound. The same explanation that compound C has 2 atoms of element A and 1 of element B makes us understand this. Yes, if we scan compound C, we will always find 2 atoms of element A and 1 atom of element B in a single unit. And this is applicable for all compounds. We've already looked at 2 examples, water and carbon dioxide. In case of 1 unit of water, we always have 2 hydrogen atoms and 1 oxygen atom. And in a single unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. Carbon monoxide has 1 atom of each, that is carbon and oxygen. While 1 unit of ammonia always has 1 nitrogen atom bound to 3 hydrogen atoms. So the number of atoms will always be constant in a unit of a particular compound.
अभी हमने देखा डाल्टन थ्योरी में 6 पोस्टुलेट्स का मतलब क्या था। जब आगे धीरे धीरे करके और थ्योरीज डेवलप होती गईं और साइंटिस्ट अपनी अपनी थ्योरीज देते गए, तो डाल्टन एटॉमिक थ्योरी में कुछ ड्रॉबैक्स नजर आए। वो ड्रॉबैक्स क्या थे? डाल्टन ने कहा था कि जो एटम है वो डिवाइड नहीं हो सकता, इट इज अनडिविजिबल। बट आफ्टर सम एक्सपेरिमेंट्स इट वाज प्रूव्ड दैट इट कैन बी फर्दर डिवाइडेड इनटू electrons, protons and neutrons. So that postulate is crossed, यानी ये उसका ड्रॉबैक था। सेकेंड थिंग उन्होंने कहा था कि एक ही तरह के एक एलिमेंट के सारे एटम्स सेम होते हैं। यहाँ भी आगे चल के पता चला कि एक ही तरह के एलिमेंट्स भी स्लाइटली डिफरेंट हो सकते हैं। जैसे atoms of same element can be slightly different. How? हाइड्रोजन में 3 तरह के एटम्स देखने को मिलते हैं, प्रोटियम, ड्यूटेरियम, ट्राइटियम। सेम ऑक्सीजन में भी 2 तरह के एटम्स हमें मिले, क्लोरीन में। तो इस तरीके से पता चला कि उनका ये वाला पोस्टुलेट भी फेल हो गया। एक और पोस्टुलेट उनका फेल हुआ जिसमें उन्होंने कहा था कि डिफरेंट टाइप के जो एटम्स होते हैं वो आइडेंटिकल होते हैं, लेकिन नहीं, बाद में पता चला डिफरेंट टाइप के जो एटम्स हैं उनके भी मास कभी कभी सेम हो जाते हैं। जैसे कैल्शियम और आर्गन, इन दोनों के मासेस भी आगे चल के पता चला दोनों के सेम थे। ये हमें जब हमने आइसोबार्स पढ़े, जब आइसोटॉप्स पढ़े, तो ये चीजें जब हमारे सामने आई तब हमें पता चला कि डाल्टन एटॉमिक थ्योरी में कुछ ड्रॉबैक्स थे। वो ये 3 ड्रॉबैक्स थे।
Are simply defined as the smallest indivisible part of any matter. That means atoms are very small in size. How can we say this? If we take the same example of a wall, then all the bricks that make up the wall are always small compared to the complete wall, right? Similarly, basic units that form a particular matter are always small compared to the complete substance. Now tell me, how big or small do you think a single atom will be? Maybe we can take another small entity and then compare the atom to it. Can we think of an ant? Probably not. Okay. So ants carry little grains of sugar. It means grains are smaller than ants. So maybe we can take a grain of sugar. How about a sand grain, which is smaller than the grain of sugar? But we can still see a grain of sand with our naked eyes. So can you tell me something smaller than this? Yes, we know that microorganisms like bacteria are tinier than what we can imagine, because we cannot see them with our naked eyes. So is an atom as small as a bacterium? You will be amazed to know that a single cell like a bacterium is made up of millions of atoms. Astonished, right? But the fact is that the bacterium can be observed at least using a microscope. However, seeing a single atom is nearly impossible. Yes, the size of an atom is that small. So that means there will be no units to measure it either, right? No, that's incorrect. In spite the fact that it's so tiny, we still measure the size of an atom with atomic radius. The radius of an atom is measured using units like nanometers. Wait a second. Do we know what a nanometer is? In simple words, 1 over 10 to the power 9 meters gives us 1 nanometer. So does that mean 1 nanometer is 10 to the power negative 9? Yes, that's how small a nanometer is. And atoms are measured in nanometers. So imagine how small they will be. Now let's take an example of a hydrogen atom. The atomic radius of a single isolated hydrogen atom is around 5 times 10 to the power negative 11. That's like 0.05 nanometers. Amazingly tiny. Now tell me, if atoms are so small, why do we need to study them at all? Needless to say, they make up the entire globe. Yes, everything that we see around us is made up of atoms. Even our body is made up of atoms. So studying atoms in detail becomes necessary despite their small size.
डाल्टन्स एटॉमिक थ्योरी के ड्रॉबैक्स के बाद में हम आते हैं एटम्स पर. What are the atoms? An atom is the smallest particle of an element that can take part in a chemical reaction. किसी भी एलिमेंट का सबसे छोटा जो पार्ट होता है दैट इज कॉल्ड एटम, जो केमिकल रिएक्शन में पार्ट लेता है. Atoms are very small in size. Size of atom is indicated by its radius. This radius is called atomic radius. Okay? Atomic radius is measured in nanometer. जो यूनिट होती है एटॉमिक रेडियस की दैट इज नैनोमीटर. डू यू नो व्हाट इज द मीनिंग ऑफ नैनोमीटर? 1 nanometer is equal to 10 to the power minus 9 meter. So see how much small it is. 1 nanometer value is 10 to the power minus 9 meter. And the smallest atom is hydrogen atom. सबसे छोटा जो एटम है वो हाइड्रोजन का है जिसकी वैल्यू है 0.05 nanometer. Okay? Now let's see about the atoms.